So yesterday we learned two ways to prove triangles are congruent. Do you guys remember what they were?
Angle, side angle.
Angle, side angle,
And side angle, side.
and side angle, side.
Angle and
So on this one, the side has to be between the two angles. On this one, the angle has to be between the two sides. The book calls it included side or the included angle. So I kind of mentioned this one yesterday. Might have been on accident, but the one we're learning today is called angle, angle, side. What do you think that might be? Yeah, so if you have an angle, and a side that's not between those two angles, those triangles have to be congruent also. The proof would be pretty quick and easy. You guys remember, if we know these two angles are congruent and these two angles are congruent, what else do we know about this triangle? Yeah, this pair has to be congruent. So that would be like line 2 of the proof. And then the third line would be, therefore the triangles are congruent by angle, side, angle. Right? So anyway, angle, angle, side. We're adding that to the list. Okay, isosceles triangle theorem. This one's new. What's an isosceles triangle?
two sides.
Two sides are congruent. What was it called when there was no sides congruent? Scaling, when all three sides were congruent? Equilateral. I think I might have mentioned, this was like last Monday, I think, when we did the triangles. You guys remember what these two sides were called in an isosceles triangle?
The legs.
Legs, base. These angles were called
Congruent.
base angles. This was called the vertex angle. So, yeah, it can look a lot of different ways, like, it could be a right triangle, and these would be the legs. Anyways, so the theorem we're learning today is, if you have two equal sides in a triangle, then the angles opposite those sides are also going to be equal. So like that angle and that angle. So if you have two congruent sides in an isosceles triangle, basically the base angles have to be congruent. Or you can say it the other way. If I know like that angle and that angle are congruent, guess what I know? These sides are congruent. So it's the converse of that, what I just said, but they're both true. The book calls it the converse of the isosceles triangle theorem. Isosceles triangle theorem, the base angles are congruent. You don't have to say, you can just say in an isosceles triangle the base angles are congruent. That's the theorem. Or you can say if the base angles are congruent, then the legs are congruent. Okay, anyways, so if that is true, the isosceles triangle theorem, then guess what we know about an equilateral triangle?
All sides are congruent.
Yeah. If the angles are congruent and the sides opposite those angles are congruent. So anyway, in an equilateral triangle is all also equal angular. So we can use that as a theorem now too. Equilateral triangles are also equal angular triangles. Huh?
Equal everything.
Equal everything, yeah. Kind of like squares. So, what does that mean? Each angle on an equilateral triangle would have to be 60. 180 divided by 3.
Doing like 1 through 17.
I kind of forgot. I think I wrote down 1 through...
19.
1 through 14, 18 through 22, I think. Yeah, I'm pretty sure that was it. page 172. That reminds me of a joke. Did you guys tell me the joke?
The circumference joke?
No, the step ladder joke.
Oh.
Is that from you guys?
It's not my real life.
That's what Jackson.
Jackson.
I love
Jackson.
that joke.
I never knew my real ladder.
This Conrad has that, or classroom.
Oh yeah, that's right. Somebody was telling me about that. Oh yeah, I brought up. I saw in a room. Have you ever, when you're walking up a hill, tried to breathe quieter, so you don't let people know that you're
Kind of.
trying not to
Fighting
die?
for your life.
Yeah, fighting for your life.
I just crossed the country, so it's not really a problem.
Oh, okay.
Leo drops that in every
Sorry to all you
sentence.
fat people.
Stairs are rough, man.
Yeah.
It's a steep hill out there, okay?
Yeah.
Number 1. Measure of
I would know
angle.
walk out from practice.
Imagine running.
Imagine swimming.
That's running better.
That's true. BDA of BDC. Okay, so if angle, what would the angle of BDA have to be if BDC is 90?
90.
90, yes. So notice in that picture we have 2 triangles, but we also have one big isosceles triangle, right?
Late.
No, I had bottom pictures.
No, you're right.
Where's the slip?
There's enough.
Exactly.
Exactly.
So,
Okay,
Then he's gonna come to the exact same thing.
Okay, we're not buying it. Number 3, angle BCD if angle A is 50. All right.
Oh, wait, no. Yep.
So basically, here's what we got. This is 50, and they're asking for this one right here.
So,
So 50. Because it's an isosceles triangle, right? So if these 2 sides are the same, these 2 angles have to be the same. So it also has to be 50.
what do you mean, no?
I didn't know it was an isosceles triangle.
Page 172. We turned in yesterday's also. Number 5, find the measure of angle ABD.
See that? Just yell late.
Late.
I know, guys, you missed me.
We said late.
We said late. You must have misunderstood okay, so we're looking for this guy right there, and they told us this line's perpendicular, can't draw a straight line. What's perpendicular mean?
90 degrees.
Those are 90. Okay, we no longer know that, by the way. Oh, and BCE is 125. You guys see angle BCE?
Yeah.
Okay, if this is 125 out here, what else do I know?
Um,
Then,
what's 180 minus 125?
the adjacent is
150.
60.
55.
55.
55, yeah.
180 minus 125 is 55. Okay. Well, okay. Basically, if we know these are perpendicular triangles right here,
Other side.
55.
Plus 90 is 140.
and we know these. Okay, we know these 2 angles are the same, right?
55.
And we know these 2 sides are the same, so we got angle, angle, side, basically. Angle, angle, side. So the triangles are congruent. So whatever this angle is, this angle will be also. So 180 minus 90 is 90, minus 55 is, nope,
35.
35. So this is 35, so the other one's 35.
This reminds me of Monday stuff.
Yesterday?
No, I mean the last Monday stuff.
You remember last Monday?
Yeah,
I don't.
I got sick.
I don't.
Oh, you had to watch it later.
No.
No, I was there. It's
You
like
guys ready to make the announcement?
Late.
You're
late.
What number are we? Yeah, what number are we on? Seven.
Yeah. Did we do a good job? You guys can watch the video if you want. You missed some really good content. Number 7, find a measure of, don't forget to like and subscribe. Find the measure of each angle in the triangle. Okay, so what do I know about angle C and angle B on number 7?
They're gonna be the same.
They're the same thing because it's an isosceles triangle. So the little angle is 20, so what does that leave me for the last two angles?
160.
160.
Divided by 2.
Divided by 2, 80. So just put 80 degrees. Technically, I guess we should put it twice because they're both 80 degrees, but whatever. Abby says it's okay, I guess. Number 9.
Hey.
We might have to do some algebra on this one.
Oh,
If angle P is called X, then what else do I know?
Q is X.
Q is also X. What do I know about all three angles together?
180.
Yeah, 20.
2x plus X.
So X plus X plus X minus 15 should add up to
180.
180. How do I simplify this?
3x minus
Add the X
15.
3x minus 15 equals
Minus 15. Plus 50.
Okay, is that the answer?
Mm,
Yeah, kind of.
yes.
It's one of the answers. So we're supposed to say what all the angles are.
Oh.
So the answer would be 65, 65,
And then 40. Wait.
50.
50.
yeah, the third angle was called X minus 15.
Where's my calculator? Simple math. That's what.
Find the measure of each numbered angle. Okay. See if I can recreate this. Ooh, swing and miss. All right, any bright ideas?
Yes.
Okay, if this angle's 52, then what?
yeah, the size of
Vertical. Wait.
Okay, what else besides the vertical angle?
That means 48. 148. Wait, no, 130.
Wrong.
Okay, 180 minus 52, 180 minus 50,
66.
getting colder.
Oh my god.
66.
66.
Are you kidding me?
Oh, I did 118. I did it wrong.
Okay, so basically the angles, they said the numbered angles, 1 is there and 2 is there. So we're gonna kinda need the same trick, we already used this trick once. This is an isosceles triangle.
Yeah.
So if this is 128, then what?
The other ones.
You do 180 minus 128, which is 52. And then is 52 the answer?
No, divide
No,
by
these two together make 52.
26.
26. Angle 1 is 26 degrees. And we got the same situation over here. I don't know why they put a right angle right there. Confused by that, but it doesn't really matter. Anyway, if this is 52, these three have to add up to 180. So 180 minus 52 is 128. So split that in two for these two angles. 128 divided by 2 is, I'm not going to do it.
64.
Well, I guess they give you the right angle, so you can probably like add it to that.
I don't need to.
Oh, yeah, maybe that's what they're thinking. There's another, we could have done 90 minus this to get that angle, which is the same as that angle. Yeah, that makes sense. Alright, number 13. If the legs of the ladder form an isosceles triangle with the floor at the base. Alright, do you guys see the isosceles triangle in the picture?
Where?
The step ladder?
Oh, I didn't see this. Never knew.
The
about
bar.
it.
Where's the real one?
Yeah,
Same way.
the legs of the step ladder form an isosceles triangle. And the exterior angle at the vertex of the ladder measures 140 degrees. What's an exterior angle? So there's the
Or
legs.
like the continuum.
The outside.
Yeah, the angle with the floor basically.
On
the outside.
the out now.
What is the measure of each face angle?
40. 40.
Oh, no, sorry. It said exterior at the vertex
Oh.
angle.
So up to the top. What's that laugh?
It said the exterior at the vertex angle, so I should put this up here. Okay, so if this is 140, then what's this going to be?
40.
40.
Yes.
Okay, if this is 40, what's that leave for these two guys? 140.
Which is
I like
70.
70. Yep, okay. 14, I kind of said that proof in the intro. It's a 3-step proof. Can you do it?
14.
Okay, so I'll let you guys try. It's a 3-step proof. The first step is given, obviously. You're trying to prove the two triangles are congruent. You're starting out with angle, two angles, pairs are congruent, one side pair is congruent. Okay, remember what I said at the beginning? If two angle pairs are congruent, what do we know? A third pair of angles has to be congruent. You guys remember how the book wrote that?
No.
Angle, that implies an angle in a triangle. If two pairs of angles are congruent, then all three pairs of angles are congruent in the triangle. That would be a reason. And then if we know all the angles are congruent, then why do we know the triangles are congruent on 14? Hmm? No. That's if you know the triangles are congruent, then you know all the remaining parts are congruent. Okay, so if we prove, so this is the starting spot, right? If we prove this third pair of angles is congruent, that picture's not great. How do we know these two triangles are congruent?
They're equal to each angle, side angle.
Angle, side angle. So you say the third pairs of angles are congruent by this thing, and then the triangles are congruent by this thing. That's what you're trying to prove. The triangles are congruent. Okay, so if you came in late, the third, what we learned today, remember yesterday, like angle, side, and side. And then today we're adding on angle, side. Number 14 is asking us to prove angle, side is a thing. So basically they're starting with angle, side, and we're supposed to prove the triangles are congruent. So we're gonna, second line, show that the third pair of angles has to be congruent by this thing. Third line, just say the triangles are congruent by angle, side, angle. Alright, talked it to death. Number 19, is 18 gonna beat you guys senseless?
Yes.
Yeah, I'm gonna have to ask a question, I guess. Number 19. it says find the measures of 4 numbered angles. So it's kind of like what we were just doing. I guess it's in the B section, so I guess it's gonna be harder.
Yeah.
Okay, if that angle out there is 111.
The inside one is.
Yeah, this is Trixie. Okay, it's important that that's an isosceles triangle right there. And this one is also.
Something weird about my homework. Yeah, I think that's pretty.
Okay. You guys probably forgot this. Might not be an easier way. Do you guys? I wasn't sure if they marked your book like they marked my book. Okay, if these two sides are congruent, what else do I know?
The base angle.
Yeah, the base angle, these two have to be the same. And if these two sides are congruent, what do I know?
Those
The bases.
These two are the same. Alright, let's see, what else can we figure out? I don't, you guys probably forgot this. You guys remember what we knew about an exterior angle of a triangle? These two angles, I'll call them, did they call them like 1 and 2 or something?
Oh, they add up to it.
They add up to it. No, they didn't call it 1 and 2. Well, okay. They called this one 3, but if this one's 3, then basically that one's 3, right? And they called this one 1. So basically I know 1 plus 3 has to add up to that. What else do I know? Okay.
That was angle 3 plus angle 3 equals 11.
No, so I'm looking at this big triangle, right?
Oh, yeah.
So these two remote interior, an exterior angle is equal to the sum of the remote interior angles. That's 180 minus 3 equals 180 minus, yeah, okay. Well, this one right here would have to be equal to, alright,
3 and 2 equal 180.
this angle right here, I don't know, there seems like there should be an easier way, but I don't see it yet. This angle right here is equal to the sum of these two angles. Do you guys see that? Because this is an exterior angle for this triangle. Basically, this angle is 180 minus angle 3, and this angle is also 180 minus 2 of these. Anyway, 3 is equal to angle 1 plus angle 1. Exterior angle is equal to the sum of the remote interior angles. So I can use substitution right here. I can replace angle 3 with angle 1 plus angle 1. Okay. That's great. You guys see how I did that?
Yeah.
Substitution, you guys remember doing that last year? Angle 3 is equal to angle 1 plus angle 1. So how can we find angle 1? I'll be a little more technically correct here. 3 times 3 of these, right? Equal 111. So how do I find the angle 1 there? is 37 degrees. How could I find angle 3? You can see right here. Or I could use this one or this one. Angle 3 is equal to angle 1 plus angle 1.
37.
Yeah,
No.
74.
Wait, how'd you get 74?
37 plus.
Angle 3 is equal to angle 1 plus angle 1. Or you could use this one. Angle 1 plus angle 3 is 111. Okay, where's angle 2 at? Oh. And there's an angle 4 also. Okay. Angle 2's right here. There's lots of ways we can find angle 2, but how can we find angle 2? Since that one's 74, you could do 180 minus 74 to get angle 2. 106. How could I find angle 4? We could do, there's a few ways to do this one. We know all three of these angles, so we could do 180 minus, or we know these two angles. We could do 180 minus those two, or these two are 74, so we could do 180 minus 74 minus 74. Get that one. Three angles of a triangle. 74 plus 74 is 148. 180 minus 148 is 32. So angle 4 would have to be 32 degrees. Yeah, I don't think. It might be a little too hard. Okay, 18.
What was angle 4?
32.
13.
Maybe, okay. Maybe I'll just help you with the first angle on 18 and then let you guys do there. After you get the first one, kind of easier, I should say. See if I can draw that picture. Beautiful.
The line's at the top. The line.
Oh, the line, yeah.
Boy, this is gonna be as deep as Richard Torrance someday.
Thanks, Bob.
100. Alright, what angles have to be the same as pictured?
The two base angles of the big one.
Two base angles on the big one,
And the little one.
two base angles of the littler one. Okay. So if this is, let's start with the big triangle. If this is 100 degrees, what else do I know about this big triangle?
Those two angles add up to.
These should add up to 100. So what would both of these have to be? 50. That might be enough to get you guys going.
So 3 is 50.
Is it? Is it enough?
Or probably.
Oh, they put x plus 15 and stuff in there. Did not see that. That one was x plus 15. That was 2x plus 15. Okay, well, it's, what do we know about these two?
Add.
Yeah.
They have to add up to 180, right? They make a straight line together. So this plus this equals 180. What's this plus this simplified to?
3x plus 30.
Yeah. Yeah.
X equals 50.
X is not one of our angles though.
No,
Okay, if X is 50, what would this angle have to be?
65.
Okay,
So that means
was that one of our answers?
4 is and 65.
4 is 65. What else are we looking for?
So 65 plus 65 is 130. And then
How do we find angle 1 up there? So we got two angles of a triangle. We can use that to find angle 1.
angle 1 is 50.
Okay, yes, Trixie Devil. So you might guess this, but these two angles up here have to be identical.
Yeah.
The reason they have to be would be like angle side, basically. If these two angles are the same, then these two angles are the same. Supplements of congruent angles are congruent. So anyway, angle side, these triangles have to be the same. Therefore, by CPCT, corresponding parts of congruent triangles, these two angles have to be the same. Do you guys remember CPCT from yesterday? So we just found angle 1, right? What was angle 1? Man, everything's 50 on this one. So if that's 50,
25.
there's 100 over here. So we got, from these two together, we got 150. What's that leave for these two guys? 30. So if you do 30 divided by 2, that will get you one of those guys. Darn it.
Jordan, I need
Okay.
to chill.
On 20, well, I think we'll just go to 20. I'll give you a hint on 20. So that, what do they call it, pinwheels,
Yeah.
is made up of a bunch of isosceles triangles. Can you guys see it in your imagination, I guess? We can figure out what that interior angle is on those. Anybody have an idea of how we can find this angle right here
Well, there's
on one of those wheels?
There's 12 of them. They'll equal 360.
Yeah, they have to add up to 360 because they make a complete circle.
It's 360 divided by 12.
Yeah, so it's 360 divided by 12 will give you this angle. So the question is, state the measurement of the base angles. Which one's the base angles?
The ones.
That would be these two, right here. And then the vertex angle is this guy up here.
30. So 15.
Okay, anyway. So yeah, 360 divided by 12 because there's 12 of those triangles. Do it on your own.
Something popped
Number
up.
20.
What'd you do?
Yeah, that's nice. You'll find, like, what if I don't want to be a teacher?
We're like talking cat memes.
Yeah.
Yeah.
Cat's playing the piano.
That was literally used to.